All right, I want to talk you through some of the sample problems on, let's see, this section 4.2, and I'm going to work starting at number 15. We're talking about the compound interest formula. There's actually two types of compound interest formulas that you're going to see. One is when you know an increment of time, A, which is the accumulated value, what it comes out to be after interest has been added and it's grown. It's the growth value, A, equals P, which is the principal or the present value, how much you start out with, times 1 plus the rate, change it to a decimal form, divided by N. N represents how many times they compound your money per year. We use it here and here in the denominator and the exponent, and then T is time. All right, the other formula is if it's compounded continuous. And compounding just means they add your interest in increments. So not just at the end like simple interest, we just multiply interest times principal times rate times time, and we get one interest amount. This adds your interest in increments periodically, and then adds that in, and then it recalculates, compounds it. So these formulas help us do that. So this formula is a little shorter. It looks like maybe the word PERT, but it's the principal or the present value times E, which is on our calculator. We'll need to have an E value on our calculator. We then raise that to the rate times time. So E is raised to rate times time and then multiplied by P actually. All right, we'll practice that. So a sample problem here, it says find the future value, which that's the A value, the output value, after we crunch it in the formula. So find the future value and how much interest you would have earned if you invest 8806.54, so that's going to be our principal or our P value, and invest it for 7 years. That's our time T, we can see here, and it's at 5%, so 0.05 in the rate column. And then it says to compound it for A part semi-annually. So that's how many times it's compounded per year. That's our clue there. That tells us to use this incremental formula. Semi-annually means they add our money or our interest in twice a year. So the N value, you can see I put in a 2. 2 would be for semi-annually. If you're doing it quarterly, they add your interest in 4 times a year. Monthly would be 12, and so on. So again, N is how many increments of time per year, and then T is how many years total. All right, so you can see I've added in all those values, and then we have to get that out of our calculator. So here's a sample way to put it in most calculators. We write in the principal. Some of you have to put in a little time sign there, and some just put a parenthesis, and the calculator knows that's time, so it depends on your particular variety. But you can try it both ways. So parenthesis, this 1 plus 0.05 is divided by 2. Close your parenthesis, then raise 2. Some of your calculators have an actual caret button, and some have an XY button that looks like that. Either one of those means a raised to exponential. So it tells the calculator to put these in the exponent. You need to put a parenthesis around that, or just go ahead and call it 14 if you like. But this does need to be multiplied, so your calculator will know both of those are considered exponents. So this would be your input, and this should be your answer to check your work there. So please do pause the video and practice that on your particular calculator. Then it asks you how much interest was earned. So it's a two-parter there. So it started out 8806.54, so we would have to subtract that from this now 12,443. So it's just to subtract those two values to see how much of it was growth, interest amount. Okay, the B part then, we're going to use the continuous formula. So the B part says compound continuously. Anytime it says continuously, this is our formula. So the same principle, 8806.54 cents. And then again, some of you have to put a little times there, and some of you can put a parenthesis or just go straight to the E. So again, it depends on your calculator. I don't think it ever hurts to put a time sign. I don't think any would not want you to do. Maybe put the time sign, then find your E button. Now, some of you have an EX button on your calculator screen, so maybe look for E to the X, and what that does is it makes E with an up arrow automatically, making it so it knows this is going to be an exponential spot. Normally, we do this calculation so much, this is the common way we use exponential E, that it comes that way on your calculator. Now, some of you just have a regular E button. If you only are hitting the E button, you'll also have to add in the up arrow yourself. But if you use E to the X, it does both of those for you. That's the only difference, really. It's not a big deal. So you're going to up arrow it to the rate times time, just like the last one had two parts in the exponent. So you need to parenthesis that to be most careful. So the input would be 8806.54 e to the x button, or times e to the x button. And I believe that opens up a parenthesis as well. So it'll start your parenthesis. You type in 0.05 times 7, then close your parenthesis, equals, and that should be what you get. So check that out. Notice that is just a little bit more than we got with the other method. And continuous should be just a little bit more because they're compounding your money more often. Here we had 443 and here we have 497. So, you know, like maybe 50 some bucks more by this more often. The more often you compound your money, the more your money is going to grow, right? So this will always be a little bit more money than this one. All right, so then we do that again in various ways for the rest of the problems. The next problem leaves out a different place in the formula. It says find the present value. So you're looking for P. We don't know the P value. Find the present value that will grow to 27,000. So the growth value, or that's the A value, what it grows to. And then they give us the interest of 3%. It's compounded quarterly, so that's 4 times a year. N is 4. And then for 17 quarters. So it goes ahead and gives it in quarters instead of in years there, which is, maybe watch out for that because that's kind of tricky. They've already got it in the total amount of compoundings. You know, normally when we do the N times T, it's how many times per year. Like on this one, semi-annually, so twice a year. Then for how many years? On this example, last one was 7 years. So we did it twice a year for 7 years, or for a total of 14 total compoundings. So this N times T is always the total amount of times they roll your money over or compound the interest onto it. So in this example, it just do it for a total of 17 quarters. They've already got it in N times T form. So N times T is already kind of calculated for it. It says 17 total because they've got the years aren't actually on there. If we divided 17 by 4, that would be how many years they did this, but that would be kind of working backwards. So here's the inputs. You're looking for P, so P I do not know. The A value is given 27,000. 1 is in the formula, 0.03 for the percent, divided by N is 4. And then, like I said earlier, they've already got the N times T in its form there. So we just need to solve this. We kind of have to work backwards. We work all of this out on our calculator by typing in 1 plus 0.03 divided by 4. Maybe hit your equal button. Then X to the Y, or your caret button, up to the 17th power equals. It's going to be some long, awful decimal. You can see I've got that here. But what happens, because it's by P, it's times onto the P value, we'll have to divide on this side, right, to solve. Just like if you had 6 equals P times 2. How would you solve that? You'd have to divide by 2 on each side to solve for P. Same thing here. We got P times a something, so we've got to divide off that bunch of stuff to get it to cancel. So again, to get it from this side, because it's times onto this side over here, it's a divide problem. So that becomes under the 27,000, right? So P will equal 27,000 divided by whatever this calculation is. So you can do this in your calculator and maybe not do any rounding, but if you're going to write it out, keep like 6 or 7 or 8. I really can't tell you absolutely how many place values, depends on the problem, but you don't want to round to tenths here. If it says round to tenths at the very end and you round in tenths in a preliminary step, you're going to miss some pennies. You're going to be off by just a little bit. So you want to keep a lot of decimal points, or better yet, don't round at all. Just keep that number saved in your calculator and then say 27,000 divided by, pull up that last calculation in your calculator. Calculators have an A and S button. I don't know if we talked about that in some previous videos, but many calculators have this A and S button. It's over your minus key. and you can say, pull that last answer up that was in your calculator, and it'll keep the 10 digits, so it'll be a little more accurate that way. That's what I recommend. 27,000 divided by that calculation. But anyway, you should come out with, to the nearest penny, $23,779.23. That will be what P would have been, how much I would have had to have invested in the original present value or principal, and then times it by the 3% interest quarterly for it to grow to 27,000. So this is the principal that grows to 27,000 under these conditions. Okay, next problem, number 17 is similar, so we're going to practice that again. It's very similar. We've got the A value, but we don't have P, so here's our formula that we have to use. So again, we have the A. A is 3,000. I don't know P. I'm finding the present, finding P under these conditions. It's 7.5%, so we always change that to a decimal by going to left. So I'll put that in for R. N is quarterly, so quarterly is 4 times a year, so 4 for N. And then here it does have T. T is 7 years. So when I put in 7 years for the T, 4 times 7, there's 28 total compoundings. You can just go ahead and calculate that if you like. Okay, so to solve that, I'm going to type all this in my calculator again. So 1 plus 0.05 divided by 4. Get that calculation, raise it to the 28th power, and get that long, ugly decimal. You can either save it as your last answer like we talked about before, or just write down a lot of decimal places. But we're going to have to divide that when we're solving for P, because P is times this side. To get this off of this side over to here and solve for P, we have to divide that number. So I divide by the 1.68226 number. Divide that to each side, so it becomes 3,000 divided by that last answer, which should give me $1,783.31. Again, you expect the P value less than the value. This is what it was before the principal or the present value before it grew to that. So it should be smaller. The answer should make sense, right? Okay, then lastly, number 18, we're solving for yet another spot in this formula. We're solving for the interest, or the R value. It says find interest, annual interest rate to the nearest tenth of a percent. We've got $1,300, that's our P value, growing to, so that's our A value, 1,800. So again, 1,800 is the bigger value, what it grows to. P is 1,300. Then we've got the 1 plus rate. That's what we don't know on this one, right? We're solving for rate. Divided by N. N is 4. It said in the problem quarterly. So quarterly means N is 4. And it goes here and here. And then time, and this one is 10 years. So times 10, or in other words, 40 total compoundings. All right, so to solve that one, we've got to do some fancy equation solving, kind of work backwards. So we can't actually work what's in the parentheses first because I don't know the R value, so you can't calculate that. So we start working backwards with our algebra, you know. We can divide out the 1,300 because that's a time, so divide gets that over to the other side. Okay, so that leaves 1 plus the R over 4, 4 for the quarterly, raised to the 40th. And instead of calling it 1,800 over 1,300, I just reduced it to 18 over 13, or you could go ahead and get your decimal value. Then, this is the new thing, I think, for this one. To get rid of the 40th power, just like if this were squared, you would square root to solve, right? So 40th power, our 40th root. So I have to take the 40th root, if I have the 40th power, to undo that to bring out the 1 plus R over 4. So again, whatever that power is, we take that root. We don't oftentimes take the 40th root, I know, but we can do that on our calculator, and we'll talk about that. But anyway, that releases this parenthesis, 1 plus R over 4. Now, we got the 40th root of 18/13. That is on our calculator, not directly though. Some of you have an X root button. All of you have a square root button. Some of you have a cube root button, but probably no one has a 40th root button. But you may have an X root button, so you type in 40th, 40, then the X root, then 18/30. That would do that. If you don't have an X root button, no problem. The other way to do that is say that means 18/13 to the 1/40th power. So we can all do that. That means the same thing. 40th root is the 1/40th power. So either way will work. So we can calculate that. Then we'll minus the 1, bring the 1 across, and then all we have to do is times by that 4. So let's look at that up here. So the next calculation, I needed to get the 1 across the line, so it was a positive 1 brought across as minus 1. And then because r is divided by 4, last step was to times by 4. So finally, getting r alone will be 4 times that 40th root of 18/13, whichever method you're going to use there, then minus the 1 from that, get that calculation times by 4. Or, like I said, you can do 18/13 to the 1/40th power, equal that out, subtract the 1, equal that out, and then times by 4. Or you can probably just type it directly like I have here. Sometimes I just as soon just do it order of operation as I work with all the parentheses. But that should give you 0.03267 decimal. So as a rate, we'll move it to right to make it a percent, which is 3.267. And to the nearest tenth of a percent, that's right here, this 2 is going to round up to a 3, making it 3.3%. So do practice that, and let me know if you need further examples. Best wishes. Sorry, I can't get my video to turn off there. Still